Okay, in this video we are going to verify some trig identities again. So this is actually part 4 of a series of videos I've been doing. And to verify any identities, you really need to know the 8 fundamental identities, the reciprocals, the ratios, and the Pythagorean. In this particular video, it's really important that you know all of them because the strategy we're going to use this time is actually to convert everything we see to sines and cosines and just do a lot of algebra. So I've already done a video on breaking fractions up or combining fractions. I've done one on distributing and or factoring. I did one on multiplying by a clever form of 1. And in this video we're going to convert everything, which often involves all of the other strategies because usually this is a last-ditch effort. So these tend to be more difficult, but the first example we look at is actually not going to be all that difficult. So we have 1 over 1 minus cotan equals sine over sine minus cosine. So you can work on either side. I'm going to choose to work on the left side to begin with. My strategy is going to be to change everything into sines and cosines, so the only thing to do is really use the ratio identity on cotangent, make it cosine over sine. So this now, I'm going to, in the denominator, I'm going to get a common denominator. So I'm going to use 1 minus cosine over sine, and I'm going to rewrite that as 1 over sine minus cosine all over sine. So I'm skipping more steps in these than I did in previous videos because these are usually more challenging. So you'll end up writing a million steps if you show everything. So this is, I have a fraction divided by a fraction, so I'm going to multiply by the reciprocal. So I get sine over sine minus cosine, which is exactly the right-hand side, and so we verified it. So it's really, this one's kind of simple, but it does illustrate the point. But what I want to do is I'm going to do this one again, except I'm going to focus on the right-hand side this time. So I'm rewriting it so that the right-hand side is the left-hand side. So I swapped sides. Kind of an advanced technique you can use is if you look at the right-hand side here, you see this 1. And if you look at the left-hand side, in kind of the same relative position, you see sine of x. So a really good strategy on problems like this is to multiply the top and the bottom of the left-hand side by the reciprocal of that thing. So I'm going to multiply the top and the bottom by 1 over sine of x. So I get 1 over sine of x over 1 over sine of x. So that's just a very clever form of 1. I'm going to multiply that by the original. And already if you're thinking of 3, you can kind of see what's going to happen here. This is going to give me, I have sine of x over sine of x when I distribute. And then that's all over sine of x over sine of x because I'm distributing, and then minus cosine of x over sine of x. And so it's kind of like in one step here. I get 1 over 1 minus, and then cosine over sine is cotan. And that's the original right-hand side. So just by taking the original and multiplying everything I see by 1 over sine of x, or really just dividing everything I see by sine of x, I get to the verification without a problem. Let's do another example. So we have sine squared minus tan squared over 1 minus secant squared. And so this one, I'm going to first rewrite everything in terms of sines and cosines, because it's not really obvious to me what strategy to use at the outset. So tangent is sine over cosine, so tangent squared is sine squared over cosine squared. And then secant squared is 1 over cosine squared. So now at this point it looks like if I kind of want to like clear the denominator, so what I'm going to do is I'm going to multiply everything I see by cosine. So I'm going to do cosine squared over cosine squared, which is a clever form of 1, and I'm distributing it to everything. So this will give me cosine squared times sine squared, and then minus just sine squared, because the cosine squareds cancel there, cosine squared, and then just minus 1 because the cosine squareds cancel. This I can actually factor sine squared out of the numerator, so I'm going to have sine squared, which gives me cosine squared, and then minus 1 all over cosine squared minus 1, which is really nice because the cosine squared minus 1's cancel, and I get sine squared equals sine squared. And that's what I wanted to verify, so I'm done. Alright, so that's just 2 examples. Really, I did one of them 2 different ways, but 2 examples of how you can change everything to sines and cosines and then just do a bunch of algebra. And it's an effective strategy, it's just not always the most efficient strategy. But I hope you found this helpful, and good luck.